What's up everybody, my name is Smoke with Smoke Arts and Moonraid Studios. Today we're going to be learning GDScript together because I want to make 3D games in Godot eventually, but I don't know how. I have absolutely zero idea where to start with Godot. I have zero idea where to start with 3D. This is going to be a journey that we go on together. However, I'm going to start with learning the script. I think that's a pretty integral part, so we're going to start there. And if you also have no idea what you're doing, I'm so happy to have you here so we can learn together. I'm going to be showing you a free resource that I'll link in the description that you can do on your own time as well, if you're more of a hands-on learner rather than a watcher. But yeah, this is also not a tutorial, so don't expect to learn anything from this unless I maybe also learn, because I'm going in completely blind with a heart full of hope. So, we're gonna go into GDScript. My plan for this video series is 3 lessons per video and 9 videos because there are 27 modules that the free program teaches. So yeah, let's get into it and let's see how this goes. Alright, so this is the startup screen. It's called Learn GDScript from Zero, which is where I'm starting, so that's perfect. For Godot 4, I believe 4.4.1 is the most recent release. I checked it this morning. This is probably still relevant though, I would imagine, and it seems to be an ongoing project from what I could see, so I'm pretty sure it's up to date, so let's start. Oh, actually wait, let me select the lesson so I can show you guys everything. So lesson 1 is what code is like, which I think is just kind of like logic. I went through up to about lesson 6 by myself before I decided to do this video series, but basically I got to lesson 6. We were talking about function parameters. It's pretty easy to follow. I think it's just the fact that I'm coming from being like an absolute like baby, like coding baby, that I didn't really know what I was looking at, so like my learning may not have been optimized, but every day I watch videos on Godot and I come back and do this every now and again, so like yeah, it cements itself a little bit more every time, which is what I think you're going to have to do too. It's kind of like a constant exposure, just like learning a real life language like Spanish or French or Japanese or German or whatever your non-native languages. So I'm not going to ramble on. We're going to get into it. Lesson 1, what code is like. So I'm going to be narrating this so you guys can actually listen. So if you want to listen to this series and learn, you will at least have like an audiobook version of it, kinda. So the only thing I'm not going to read out to you is the examples, obviously, because what's the point? I don't know what I'm reading yet. So. But what code is like. Learning to program can be daunting. Yet, you want to make video games, so there's no way around learning to program. Every video game is a computer program, telling the computer what to do. Programming is the process of writing precise instructions that tell a computer how to perform a task. A game's instructions are, for example, moving a character, drawing a life bar, or playing a sound. To do any of that, you need to learn a programming language, a specialized language that tells the computer what to do. And I'm sure most of you coming into this know that. The basic of basics is that a computer programming language, computers don't read English, they don't read any human language, so we have to talk to them in their language, and that's what programming is. I know what it is, I just don't know how to do it. So that's what we're here for. Programming languages are different from natural. Oh, look, there we go. They just reiterated on that. Our programming languages are different from natural ones like English or Spanish. The computer does not think. Unlike us, it can't interpret what you tell it. You can't tell it something vague like draw a circle. Which circle? Where? What color should it be? How big should it be? The computer needs exact instructions. To draw a filled circle, the computer needs to know exact drawing coordinates, the radius, the thickness, and the color you want. The code to do so may look like this. Okay, so click the button to run the code and see the result. Okay, So, yeah, right. Okay, so uh, here, I'm assuming this is probably like a function from what I've learned. So, like, draw a circle, vector 2. So, I'm assuming, like, this is all assumptions, but I'm just breaking it down for myself to understand as well. So, this is probably a vector is something drawn mathematically. So, let's see the coordinates. So vector 2 0 0. So I'm assuming this is like coordinate 0 0, which 0 0 is top left, but this is in the circle, in the center, so I'm not quite sure about that. 60. So the radius. Okay, so it's probably 60 pixels, or so what, 120 pixels, because radius and diameter are like, radius is the half of the diameter. So um don't quote me on math. This is probably another reason why I'm not like naturally inclined to programming. I am so not a mathematician. Oh my goodness. And the color is dot aqua. So I don't know if that's like a something stored in the engine that they can call to like make it that color, but yeah. So that's that example. In the following lessons, you'll learn how this code works. For now, we want to give you a sense of what computer code looks like. In this example, right, okay, so that was an example, just an example. Everything matters. Each parentheses, capital letter, period, and comma. That I do know. Everything is so incredibly hairpin, hair trigger, has to be correct in programming, or else like it just won't work. The computer always does exactly what you tell it. No more, no less. It blindly follows every instruction, which is basically what I just said. So when you program, you're the one in charge and you're free to do anything you want, which is also why I love computers. Just a quick little side rant. That's why I'm such a freaking nerd for computers. I just love the freedom and like video games, and how you can create anything you want with technology is just so awesome. So how do you give constructions how do you give instructions to a computer? You use a programming language, and so it'll give you little small quizzes like this, and it'll let you know if you're right, and you have unlimited guesses, so even if you get it wrong, it doesn't matter. But you'll learn to code with GDScript. In this course, you'll learn the GDScript programming language. The name stands for GDScript. This is a language by game developers for game developers. You can use it within the Godot game engine to create games and applications. It's the language used by games like Dome Keeper and Brotato. I have never heard of these, but I think these were um, made by the guys who made this. I might be wrong about that, but I saw something about that in the lessons. Engineers at Tesla also use it for their cars' dashboards. Oh, nice. Okay. GDScript is an excellent language to get started with programming because it's specialized. Unlike some other languages, it doesn't have an overwhelming amount of features for you to learn. That is true. Um, Part of like learning an engine is learning the ins and outs, the programming, and that's not even just for programming. That goes for like all the how you import graphics and all this stuff. Like, so the great thing about Godot is that it seems to be really simple for people like me who are like just trying to get into game, like 3D game development or game development in general. There are easier programs to start with, but I kind of want to push myself, which is why I'm doing this. But most programming languages are similar. Don't be afraid of being locked in. The concepts you learn in your first programming language will apply to all the others. Most languages have more similarities than differences. Once you learn one, it takes much less time to become productive with the next one. Here's an example of the same code in 3 different languages: GDScript, JavaScript, and Python. Try to spot the similarities and differences. Okay, so we have like GD, Java, and Python. So we have a function, the name of the function, the parameter. I'm assuming this is probably the variable here, and then if, I don't know if that means like less than or equal to, or minus equals amount. Wait, okay, so function, take damage, amount, health minus amount. If health is less than 0, die. Okay. Yeah, okay, so that makes sense. So function, take damage, yeah. And I just see small little things like here's your stop for GDScript, and then here's, I guess, like where you actually, I don't, maybe the parameter starts here. because I think this would be the in parameter of the function, I guess. Either this one or this one. I'm not quite sure why this one's here. I don't know Java. I don't know Python. I don't know anything. I don't know anything about programming. So Python would be so define, I think that's what it means, like definer, definition, take damage, parameter, stop, health. Yeah. They said GD is very similar to Python. So okay. So yeah, I get the basics of what they're saying here. It doesn't look that different, does it? No, it doesn't. Our programming languages all completely different. If you learn from one language and then you want to learn another, well, you have to start from scratch. No, they have many similarities. This is a course for beginners. If you want to learn how to make games or code, but don't know where to start, this course should be perfect. We designed it for absolute beginners. But if you already know another language, it can be a fun way to get started with Godot. We will give you the coding foundations you need to start making games and applications with Godot. Please be patient. It will take time for you before you can make your first complete game alone. And I absolutely believe that. I'm just letting the process take as long as it takes. Learning to make games takes practice. Creating games is more accessible than ever, but it takes a lot of work and practice. Don't expect any single course or book to turn you into a professional. Right, this is just foundation building. Programming is something you learn through practice. If something doesn't make immediate sense, don't stress it too much. Keep learning and come back to it later. Enjoy the process and celebrate every little success. You will never stop learning as a game developer, which is part of why I love game development. Like, you're always figuring out problems and developing yourself, like, as a person too, and like expanding your mind. But this is what and how we'll learn. In this free course, you'll learn the foundations you need to start coding things like this. So inventory, items, variables, I guess you could consider this pathfinding, graphics, characters, all that good stuff. Along the way, we'll teach you some of the mindset you need as a developer. Too many programming courses skip that essential part. Absolutely agree with that after all the YouTube videos and everything I've watched. How to write GDScript code, essential programming foundations to get you started. As you go through this course, you will have many questions. We will answer them as best as we can as we go. But there is so much to cover that we have to take a few shortcuts. We don't want to overwhelm you with information, and we also want to respect the pace at which our brains memorize things. We broke down the course into short lessons and practices. If we put too much into each part, you'd learn slower. If at any time you're left with burning questions, they do have a Discord community right here. Is this for Godot 4? Yes. We initially designed it for Godot 3, but there's still the same foundations in 4. So programming is a skill. So to get good at it, you must practice. It's why we built this app. Each lesson is followed by an interactive practice to use what you learned. Speaking of which, it's time to look at the practice screen. Oh god. Okay, so now I'm going to embarrass myself. To continue, click practice. Okay, so we're going to try our first code. So this is what the screens look like when you are in their little built-in interface that teaches you how to do everything. So we have a function _ready, and it prints welcome. That's essentially all this is saying. So we prepared a sample code for you. For this practice, you don't need to change anything to test the code. You hit run. Test the code? Test the code, you hit run. So basically, low guy waves, and it prints welcome. I didn't see where the console was, but there we go. The console's right here on the bottom right. So, alrighty. Your first error. So when you program, you're bound to run into errors. Tons of them. I do that with visual scripting, like drag and drop stuff. So you'll definitely do it when you're typing it, but you shouldn't worry. On the computers, errors are a good thing. You'll encounter errors, and that's okay. Every programmer does, especially professionals. At school, you maybe learned that mistakes are a bad thing. When you code something, it's not the case. Errors help you write correct programs because they show you what's wrong in your programs. A code error looks like this. It's a message that tells you some of your code doesn't work. And the example is the function move already exists in this class. So I agree with this. I'm going to go on a quick little theory rant. I agree with this because ever since I was a kid, I've always learned better through failure. I think it like helps cement the proper thing in your brain once you get the proper thing down. I don't know. I guess it's like some kind of psychological reinforcement stuff, but like I've always found that actually making errors helps my brain remember what not to do and then what to do, because if you know just what to do, that's great, but like if it breaks, you won't know how to fix it. So if you make a bunch of mistakes, you'll go like, that doesn't work, and okay, I see why. That doesn't work, oh okay, and I see why. That works, but this doesn't work, and I see why, so let me da 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 da, and then oh look, now it all works, and now I know why for the future not to do that, and if it does break, I know how to fix it. So making errors friendlier. Error messages can look a bit cryptic. That's because they're designed by programmers for trained programmers. We added an error translator in the app that'll help you get started. It shows you why an error happens and what the message means. It also gives you some tips on how to fix it. So the example they have here is the function move already exists in this class at line 22, and that's the same thing as here. Why this happens. You're trying to define a function or a variable that already exists. You can't do that. Perhaps the function or variable already exists in the current code file, but it also may be in a parent class that this GDScript code extends, and how to fix it is in the app. Your code extends some built-in Godot code that's not visible to you. When that happens, you either need to rename your function or variable to one that will not collide with an existing one, or just remove the line of code. Which makes sense. Okay. So error messages are designed on purpose by fellow programmers who came before you. They anticipated you might have specific issues and wanted to help you fix them. You shouldn't think of errors as failures. They are like mentors helping you from the past. Importantly, errors won't break your computer, at least not with GDScript, because it's a pretty safe language. Ultimately, you want to fix all the errors in your program. Understanding what is causing the errors with the help of error messages is key to fixing them. Any error messages are a bad or good thing code. They're good. They're there to help. Ta-da! I want to tell you a quick funny story. I was working in RPG Maker and I ended up like on breaking your computer. I was working in RPG Maker and I have an event that was set to parallel, and I couldn't figure out why my switches turning on were not stopping the event, and I had this like constantly looping event that almost crashed my laptop. So that's really funny. You'll run into stuff like that where it's like, oh, I did break my computer because I just set things up the wrong way. But let's see an error in action. Once again, click the practice button to see. Okay, so we're going to fix our first error. So function, this code is wrong. This code is incorrect and will cause an error when you try to run it. The code defines an empty function, which is named this code is wrong. To work, the function should use the return keyword. But this keyword is currently inside a comment, which the computer ignores. Right. Okay, so comment is the hashtag or pound, whatever you want to call it. I grew up with pound. I got indoctrinated into hashtag as a frontline Gen Z, but hashtag return. So this code, to work, the function uses a return keyword. To test the code by pressing test the current code by pressing the run function. So here in our console, we get the output error. Indented block expected after declaration of this code is wrong function. Sometimes errors are reported outside your code. Okay, so basically what I've learned so far is when you declare a function, you have to actually make the function. So this function has no function. It has the declarative state here, whatever you want to call that. I'm just going to call it declarative because I don't know the proper terminology, but it has declarative, which is like calling what it is. This is what you're naming it, and this is your parameter, and this is a stop. I'm not quite sure if this is a stop in this situation, but usually what do you call it? This thingy, semicolon is a stop. I think in Python or C something, I can't remember, but I'm gonna try not to confuse you guys with too much rambling. Okay, so be careful not to remove the spacing before return, which is this. So I'm actually gonna remove it though, just so you can see that's the indent, and that's what's critical. So you'd hit enter, and this automatically indents for you, but if not, you would just hit tab, and it does the exact same thing. So let's see, hints. Oh, no, I don't want hints. Okay, so remove the error. So this is where I actually have to start thinking. So the code is incorrect. The code defines an empty function. It has to use the return. So we're just case sensitive. There we go. Return. So run. Okay, that's literally all it was trying to teach us, is that you have to have a return function there. Continue. We stand on the shoulders of giants. As programmers, we rely on a lot of code created by others before us. Every programming language comes with a wealth of features created by other programmers to save you time. We call a bundle of code created by fellow developers a library. Was that English? We call a bundle of code created by fellow developers a library. There we go. Um, it's a bunch of code sitting there waiting for you to use it. Game engines like Godot bundle many libraries together, and they provide a massive toolset to save you time when making games. Yay! You'll always use a lot of existing code. When coding, you always use a lot of code from developers who came before you. In a moment, you'll write your first code. You'll use functions created by the Godot developers. A function is a list of instructions with an exact name. We can tell the computer to execute all the instructions in a sequence with that name. Calling functions. When you tell the computer to execute a function, we say you call it. To call a function, you write its exact name, followed by an open and close parentheses. To call the function named show, you would write show, open and close parentheses. In Godot, calling show, open, close makes something visible, like a character item. The complementary hide function hides the entity. So, okay, those are built-in functions that are quote-unquote like global functions you can call in the engine because the engine knows it. Once an entity is visible, calling show again doesn't have any effect, right? Because the computer already processed that code, executed it, and it's there, so it's not going to show twice. So similarly, once you hide something, calling hide again doesn't change anything. Click the run button on any example to execute the code. So we're going to hide it. And if you reset it, it's probably setting it back somewhere. So, but if you run it, this hides that. This is the show, this is the hide. So in the code listing above, we write the function call hide in a new function named run. Okay, hang on. In the code listing above, we write the function call hide in a new function named run. Oh, okay. Oh, so it's like a function within a function? Huh. So creating a new function is necessary to execute instructions in GDScript. Okay. In GDScript, unlike some other languages, we must write our code inside of custom functions. You'll learn what functions are and how they work in great detail in the course, but here's a quick look at them if you're curious. A function is a bundle of code you can execute anytime. It's a named list of instructions. To define a function, you need to write the func keyword, the function's name, parentheses, and a colon. Okay. So func run defines a function named run, right? Okay. So you then go to the next line to write the function's body. That's the instructions of the function. Notice how each instruction starts with a leading tab character. The computer uses that to know which lines are part of the function, okay? Throughout the course, you'll see many functions called run. Those are functions we created to give you interactive examples. Okay, so arguments. We use the parentheses to call functions because you can give the function arguments inside the parentheses while calling it. Here's a sprite standing straight. If we call the rotate 0.3 function, the character sprite turns by 0.3 radians. So if we run that, he turns. Cool. The 0.3 part between the parentheses is the function's argument. Arguments are values, numbers, bits of text, and more that change how the function behaves. Okay, so arguments let you fine-tune the effect of a function call. They can be optional at times, but functions often require arguments in order to work. For example, calling rotate without any argument would result in an error. Without an argument, Godot does not know by how much you intend to rotate the sprite. Okay, makes sense. Don't worry about memorizing what arguments each function requires or accepts. As a programmer, the documentation will always be close for you to refer to, which is something I need to get in my darn head is look at the documentation to help you. I always try to figure it out on my own, and I'm like, I don't even know what to say. And it's just like, well, go look at the freaking instruction manual, you dumbass. Like, Don't worry about memorizing blah, blah, blah. Finally, notice how we use a dot in the number 0.3 above. You need to use a dot like this to represent decimal numbers. You can't use commas as they have a different purpose in code. And I remember this from my initial bout with this, but I'll read it out for you guys. What are radians? The value of 0.3 is an angle in radians. In daily life, we're used to measuring angles in degrees. The radian is another scale commonly used in video games and math. You can convert radians into degrees by multiplying them by 180 and dividing them by pi. So the formula goes degrees equals radians times 180 divided by pi. An angle of pi radians corresponds to 180 degrees. This is where they start losing me because I can't see it in my head, but this is how it goes. It's there. And 2 times pi is a full turn 360 degrees. Okay, an angle of pi radians corresponds to 180. And 2 times pi, so 2 times, wait. Yeah, see this, okay, I'm not gonna confuse you guys. I'll think about this on my own time. But okay, so how do radians work exactly? Radians are a way to measure angles based on the radius of a circle. To get the angle in radians, you take the circle's radius and wrap it around the circle. Okay, the angle is 1 radian because you are wrapping around the radius 1 time around the circle. The perimeter of a circle is 2 times pi times the radius. A full turn 360 corresponds to 2 times pi radians. You need to wrap the radius of a circle 2 times pi around the circle to make a full circle. Oh my god. See, this is where I start getting confused. When they put actual math in it. What does the code do below? Show. Okay, so it calls the function show. Oh, see, I was wrong. Okay, so like literally it's both. Duh. Okay, so it does both. I forget that. There are some like double, triple, all of the above answers. Another example with the move local x function, you can move the character to its left and right. The function takes 1 argument, a number of pixels to offset the entity. Okay, so we're gonna make the sprite move. The complementary function move underscore local underscore y makes the character move up and down. This is one way to move a character in a game, though we'll see more powerful ways to do this later. So I think this is like the bare bones way of like making a character go somewhere. So if we reset this just to see, so it says move local x 20, so on the horizontal plane. He moved 20 and then he moved 20 down. So he's moving 20 down every run. So 20 right, 20 down. So also, in case you don't know this, positive y in game engines is negative. So he's moving, y here is positive, but he's moving down. So I know it's like super backwards. It's like backwards from everything you learned in math, in algebra, was it? I don't remember, but I took algebra and that's what we learned. So, but yeah, yeah, look, there you go. There it tells you right there. With positive values, 20, the code above moves the robot right and down. This is probably different from what you studied at school in math classes. The horizontal axis points to the right, like here, but the vertical axis points up. In video games and generally in 2D computer graphics, the vertical axis points down instead. So whenever you move something on the axis with a positive value, it'll move down. What is the syntax you use to call a function in general? Okay, so you would write its name followed by an opening and closing. You write its name followed by a colon. Write a number. Wait, look at my opening. Yeah, okay. Okay, so here's the practice. So we're going to make the character invisible, which is the show function that we learned about. So our robot character is invisible. Call the show function to make it appear. So, okay, so we have function and run, right, which we learned. And then please call show inside the run function on line 2. So it's literally just, oh, see, I'm mistyping already. on line 2, the computer needs to understand your code. Okay, so I think that's correct. Yeah, we did it. Okay, so continue. Make the robot upright. So the robot was turned by negative 0.5 radians. You need to make it upright by calling the rotate function. So we're gonna rotate, and then please call rotate, and inside the run function on line 2, keep the tab, blah, blah, blah. Okay, so I need to rotate him by this amount, and okay, so this is like the bad part. This is where like the math starts to get me. Okay, so it would be, I can't even begin to fathom. Okay, so I'm gonna take a guess. The great thing is half the time you can take a freaking guess and just hope it works out. Nobody's asking you to get it right. So, oh, I'm stupid. He's negative negative 0.5, so we want to rotate him by 0.5. Okay. Not a math person, guys. I'm an art person. I'm an art and English person. Don't get mad at me. I'm learning. I told you this wasn't a tutorial. I told you I'm not smart. So, but that is the lessons for today. So, that was the first through the third lesson of the online Godot GDScript course that we will be going through. And as you can see, I am most definitely a noob. I'm doing this as much for myself as I'm doing it to take you along with me. I hope you learned something with me here. I think it's just fun to like share this journey with other people. I think experienced programmers will probably find it funny because they all, we all have to start somewhere, and they all came from the places that we were. Like, nobody's born knowing how to code. So yeah, I just think this will be a really fun series, and I'm actually really excited to do this, and I really hope you guys learn with me. And hopefully by the end of this, I have some foundations to actually start building my 3D games in Godot. So thank you guys so much for watching. I hope to see you in the next episode and continue learning with me and expanding our brains and learning the joys of game programming. See you guys.